In this video, we're going to be investigating potential dividers and how to work out the voltage across the two resistors. To begin with, let's set up a simple potential divider. We have two resistors, R1 and R2, in series, and we'll attach across those a power supply providing us with our standard voltage. One thing we can say, because they're in series, is the current I going through each of them, is constant. It's a series circuit, so the current going through both resistors is the same. That allows us to work out the voltage going across each of them in terms of their resistance. So if we take the first resistor, V1 would just be the current going through it, which I've called I, times R1. And the same for the second resistor. The voltage across that resistor would be V2, which is I times R2. From this we can immediately see that if we do V1 over V2, the ratio becomes, well, let's put an intermediate step in here, IR1 over IR2, the I's cancel, and so it's just the ratio R1 to R2, which is the ratio of the resistances. So in other words, if one of the resistors has twice the resistance of the other, there will be twice as much voltage across it. But we can do a bit better than that. If we now say that the current I going through these is given by the total voltage V over the sum of the resistances, then in this case we can say if V1 is I times R1 from before, then the voltage across resistor 1 will be VR1 over R1 plus R2. Let's call that V1. And similarly, V2 will be VR2 over R1 plus R2. This should end up with the same result as before, but is an easier way to calculate the voltage across it if we just want to know the voltage across one of the resistors. The uses for these potential dividers typically are putting a sensor into one of the resistors, such as a thermistor, that will change its resistance when the temperature changes, and therefore the voltage across it will change. This can then be measured or used in a logic circuit or something similar, and what you have there is a temperature sensor. You could use an LDR and have light intensity changing the resistance of the LDR, put that into a potential divider, and suddenly the voltage across it changes, because the voltage is always in the ratio of the resistances, and therefore if the voltage is higher, that means the resistance of the LDR is higher, indicating low light levels, etc.